There are at least two approaches that you can take to graph data modeling. With the data-driven approach, you basically populate the graph and rely on DSC Graph to generate the schema for you automatically as you load data. This can be really useful if you have a completely representative data set, want to get started quickly, or prefer to think in terms of instance data instead of abstract schema. On the flip side, if you're more scientist than hacker, then you may appreciate using a more formal data modeling framework where you will use a well-defined methodology to work through your conceptual, logical, and physical schema designs. So let's talk about how you might go about defining your schema using a data-driven methodology. The most important thing here is to ensure that you have a completely representative graph instance that accounts for all possible graph patterns, including how vertices can be connected and what value properties might be assigned. Because remember, when DSC Graph is automatically populating your schema, it can only be as accurate as the example instance data that you're providing. If you encounter data later on in the process that was not represented in your initial graph instance, then it may not conform to the automatically generated schema. Now that might sound kind of complicated, but we're going to work through an example data-driven approach so you'll see how it all works. These are the steps we're going to follow. We'll start by drawing a picture to help us formulate our idea. We'll create instance data, and lastly, we'll visualize that data to verify its correctness. Once we're reasonably confident that our instance data is good to go, we'll take a look at the resulting graph schema and make the necessary customizations and optimizations. So here you can see a diagram of an example instance graph. In our case, we're building this manually, so our goal is to figure out the minimum amount of instance data necessary to completely represent the different things we'll see. And just as an aside, it's also common to utilize a pre-existing data set for this purpose. So now that we know what our instance graph data should look like, let's get to work creating and populating our DSC Graph instance. The first thing we need to do is ensure that our graph is in development mode. This tells DSC Graph to automatically create the underlying schema for any data that we write. Then we start by adding all of the vertices to our graph as shown here. Then we go ahead and add the edges that connect those vertices. Lastly, we add a few additional properties as shown here. Now for my favorite part. Let's take a look at the graph to make sure that we're happy with how it all turned out. DataStax Studio makes this really easy. You can visualize your graphs to ensure that it matches the sketches you created earlier. As you're inspecting your graph, there are a few things you want to verify. First, you want to make sure that you have all of your vertex and edge types represented. You will want to verify that the cardinality of all your edge labels is correct, as well as the domain and range for those edge labels, which describes the vertex labels that the edge label can connect. Lastly, you want to make sure that all of your properties are represented with all of the different types they may contain and the various possible cardinalities of each property type. Remember, the automatically generated schema will only be as accurate as the example graph instance you provide, so this step is critical. So now that we are happy with our example graph, it's time to extract our schema. DSC Graph makes this really easy by using the schema describe method. The output of schema describe method is actually schema creation code that can be used to recreate the schema later. You just copy and paste it into your application. We'll take a look at it in pieces, starting here with all of the property keys. Most of this is pretty straightforward, as our properties tend to be pretty simple, but do take notice of one multiple cardinality designation on the production property key. Here you can see the schema generation code for our vertex labels. Looks good. As well as the schema generation code for our edge labels. Also looking good. At any point during this process, it can be helpful to use the DataStax Studio schema view to see a visual representation of your schema. Feel free to check in on the fly. This representation can also make it really easy to see errors or omissions in your schema that might not necessarily jump out at you when you're inspecting the code textual output of schema describe. So what am I looking for when I'm inspecting the schema? Well, I want to make sure that all of my vertex label and edge labels are represented. That one's pretty obvious. We'll also want to make sure that the edge label cardinalities look good. Now it's important to note that these probably won't be set correctly by DSC Graph as it defaults to multiple cardinality. So if you need single cardinality, you're going to need to set that explicitly. And lastly, we ensure that our property keys and data types and TTLs are set correctly. TTL is another field that you'll need to pay explicit attention to because DSE doesn't set that automatically for you. You may have noticed that our automatically generated schema did not contain any partition key descriptions. So one final step we need to work through here is defining the user-defined vertex IDs. This is the recommended approach for getting reliable performance while maintaining the ability to control graph partitioning. Additionally, system-generated vertex IDs will be deprecated eventually. Let's go back to our vertex label schema creation code to introduce explicit definitions for the partition keys. Another important thing to recognize about this data-driven approach to graph modeling is that it's still up to us to optimize the schema by introducing indexes that will satisfy our data access patterns. So now that you've learned all about data-driven graph data modeling, go check out the exercise and give it a shot for yourself.